All right, well, welcome. In this video, we're going to be looking at how to solve equations by graphing. Now, there's more than one way to solve an equation. So when we look at this first one, you might say, man, I would not choose graphing to be my first option to be able to solve this equation. Wouldn't I just solve for x? And for something that's very simple like a linear equation, yes, that's probably true. But I'm going to show you how to solve by graphing because then that's we can use for more complicated equations. So let's go ahead and, like I said, let's look at this first one. And to make things a little bit easier with our graphing here, I'm going to change this. I'm going to make a slight adjustment to our equation. Let's change this to 8. Only because 5 on our graph here, we're counting by 2's, so 5 is in the middle, so it's going to be a little bit harder if we used 8. And you'll see why in just a second. But what we're going to do anytime we solve an equation by graphing, we're basically going to set up what's called a system of equations. We're going to solve two equations. So we're going to have one for the left side, one, whoa, what happened there? And we're going to have another equation for the right side. So let's start with writing out our two equations. So our equations, one of them would be y equals negative 3x plus 20. And the other equation will have just y equals 8. So basically you just take the two sides of the equations and make two equations out of it. One equation from both sides. So let's start with the first one. The first one that's in slope-intercept form, meaning our y-intercept is at 20, so all the way up here at 20 is going to be the y-intercept. And the slope is negative 3. Now we have to be careful because my y-axis is not counting by 1. So we don't want to say, oh, I'm going to go down 3. 1, 2, 3, and go over 1. That would be wrong. That was not correct. So we're going down 3 units. Now 3 units, I go down 3, so this would be down 2, down 3 would be here, and then to the right 1. So that would be another one of the points. Now we want to be more accurate. Technically, I only need 2 points to make a line. If you have a straight edge, you could use a straight edge to connect these and be real accurate, but I don't have a straight edge right now, so I'm going to come up with more points on my line by continuing with the slope. So we're going to go down 3, so this would be down 1 to bring us down to 16, and then 2 more would bring us down to 14 and over to the right 1. Our x-axis is counting by 1s. Okay, but our y-axis is counting by 2s. So that's where this gets a little tricky. So again, if I continued down 3 to the right 1, down 3 to the right 1, or like I said, just use a straight edge. But we do connect these. Best we can. All right. So that's our first line. And then y equals 8 would be our second line. Now that's just a horizontal line going through where y is 8. Remember, I changed that, so if you didn't make that change, make sure you change that in your notes. Just to make it easier. Oops. All right, so now the question is asking us to solve for x. Okay, so to solve for x, what we're looking for is we're looking for the intersection. The x coordinate is the solution. That's really important. So in this problem, where they intersect at, the x value is our solution. So x would equal 4. That would be your answer. Your answer is not the coordinate because we're not trying to find a y value. We're just trying to find out for what value for x would the left side be the same as the right side, and that's where x would equal 4. Now again, if you were to solve this equation, if I gave you this equation and asked you to solve for x, it probably would have been a lot faster just to subtract 20 and divide by negative 3. But what if I gave you this one instead? This would be a little bit more complicated if we wanted to solve this algebraically, so it's much easier if we solve it by graphing. So now remember, our parent functions here come into play. So this first one is going to be the absolute value function. Now think about the absolute value function is a V-shaped graph, okay? And this is going to move it to the right 4 units. So move it to the right 4. Now you look at my graph. The x-axis is counting by 1s. The y-axis is counting by 1s. It's always important to look for. So, but our vertex moved to the right 4 units and then would go up and to the right and up and to the left. So I'm just going to connect those. So there's our absolute value function. The other one will be a linear equation, and that's in slope-intercept form. Our y-intercept is 1. So it's going to have a y-intercept where y would be 1. And our slope this time is 2. So we're going to go up 1 to the right 2. Now I like this one. Now we don't want to stop there and say, oh, there's our solution. Because if we continue to the right, we're going to see that these two are going to intersect again. So I want to be more accurate. So up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. So it does look like it went up far enough on the green graph. So let's make sure they actually intersect. They do. And they intersect. Whoa. They intersect at this point where x is 10. Now, if you're not sure, you can always check it, because this means that if x is 10, both sides should give us the same answer. So if I put 10 in there for x, let's just see if that happens. So let's see what we get on the left side. On the left side, 10 minus 4 is 6. The absolute value of 6, it stays 6. On the right side, half of 10 is 5, and 5 plus 1 is 6. So sure enough, that checks out. So it's always good to check and make sure that we did it correctly. All right, so why don't you guys try this on your own? So why don't you guys go ahead and, even though, yes, you could solve this first one algebraically, I do want you to show this, demonstrate that you know how to graph this, and solve it graphically, not just algebraically. And then do the same thing with the next one. So that one involves a little bit of work, especially with that negative out in front. So just remember what we did with transformation. So I want you guys to go ahead and pause the video and hit play when you're ready to check to see if you've done it correctly. All right, so let's see if you did this first one correctly. So first off, we're going to have two equations, one for y equals 5x minus 12. And the other one is just y equals 3. Let's start with the 5x minus 12. 5x minus 12 means we have a y-intercept at negative 12, which is way down here. And let's see, my y-axis is counting by ones, which makes it easier. My slope is 5, so that means I'm going to go up 5 and to the right 1. 1, 2, 3, 4, 5 to the right 1. Up 5, 1, 2, 3, 4, 5 to the right 1. Let's go ahead and do one more. 1, 2, 3, 4, 5 to the right 1. All right, so there's my first graph, and then y equals 3. There's just a horizontal line where y is 3, and that's the only spot where they intersect at, which is right here, and that is where x equals 3. So the solution is x equals 3 for that first one. So the graphing is showing your work. So if this were a quiz or a test question, and you just did this, even if you just circled where they intersect, I will not accept that. Okay, so if you just showed your work and just did this, the graphs, you're going to lose a point. So make sure that you find where the actual x value is. All right, so if you didn't get a chance to do the next one, pause the video again and hit play when you're ready to check to see if you've done it correctly. But if you've done this one, let's check to see how you did. So we're going to again do two graphs. Let's start with this one. So again, this is based on the absolute value function. So the parent function would look like this, a v. Now the negative would cause it to flip upside down. So now my parent function, if we flipped it upside down, will look like this. And then the minus 2 means we move it to the right 2 units. So I'm just going to erase that completely. So the vertex now would be here at 2. And then it would be a V, but pointing downwards. The more graph you show, the better, only because we want to make sure that with the second graph, we want to make sure that we get enough of that first graph so when we can see where they intersect at. All right, so this one has a y-intercept of negative 2. So right there, bam, we got an intersection point. And then it's a slope of negative 1/2. So it means I'm going to go down 1 and to the right 2. We always go up or down and then to the right. So down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. Finally get that other intersection point. Make sure that we do connect these, because that's the whole point of graphing. But yes, they intersect at 2 places. So we're going to have 2 values for x. So our values for x would be x equals 0 and x equals 8. So those would be our 2 solutions for x. And again, you could check your answers to see if you've done it correctly. All right, so that's enough for this video. In the next video, I'm going to show you how we could do some of these on a graphing calculator.